All right, finalizing these last four here. So they're still four-term polynomials, so we're still going to be grouping. So we're going to group the first two here. So group the first two terms, pull out a GCF, and then group my second two terms. So grouping the first two terms, my GCF is x to the third, leaves me with x plus 2. My second doesn't have a GCF, so if you don't have a GCF and you can't pull out anything, you can actually pull out a 1. We had a problem similar to that in the previous lesson where you had a GCF of 1. So if I pull out a 1, I'm not actually changing the parentheses at all. You'll notice that your two parentheses match. That's what you want. So then when I go through, that is my first binomial in my answer. My second binomial is x cubed plus 1. I don't have any subtraction, so I can't have any difference of squares, so two binomials is how I'll write my answer. Looking at the next one, group the first two, group the second two. Okay, looking at the first one, I can pull out a 5x squared, leaves me with x minus 8. Looking at the second one, noticing that the leading coefficient is a negative means I'm going to have to pull out a negative. And x and 8 don't have anything in common, so I'm going to be pulling out a negative 1. And when I pull out a negative 1 and I divide these by negative 1, I'm going to get x minus 8, which is good because I want those two parentheses to match. The first parenthesis is my first term, so the x minus 8 is my first term, and the GCF is your second term. So 5x squared minus 1. You can write your order differently. Okay, you could write 5x squared minus 1 first, and then x minus 8 second. That's okay. All right, I just usually put what they have in common, that common parentheses, I usually put that first. But if you have your order different, it's still correct. All right, looking at the next one, group the first two, group the second two. Looking at the first two terms, my GCF is x to the fourth, which leaves me with x plus 1. My second GCF, noticing the leading coefficient's negative, so I have to pull out a negative 16, leaves me with x plus 1. So we've got x plus 1 in common for both sets of parentheses, which means I did my grouping part correctly. And then I'm left with x to the fourth minus 16. This is a difference of two squares. X squared is your first perfect square, and 16 is 4 squared. So x squared plus 4, x squared minus 4. So that is your difference of two squares. Then I'm going to bring down the x plus 1. I have another difference of two squares, so this actually happens twice. So this right here is another difference of two squares. X squared minus 4 can be x plus 2, and x minus 2. So actually, after I bring all of these other parentheses down, this polynomial, four-term polynomial, can be broken into 4 different binomials being multiplied together. And yes, you can check your answer. It would just take you quite a bit of time because you have to multiply them all together. All right, and then our last one here, see I have 4 terms, so I'm going to group the first two, group the last two. So the first two, my GCF is x squared, leaves me with 2x minus 5. My second set, my GCF is going to be 9, so plus 9, and 2x minus 5. So I have the same set of parentheses, which is what I wanted, so that's my first term is 2x minus 5. My second term would be my GCFs, which is x squared plus 9. X squared plus 9 is not a difference of squares because it would have to be minus, because difference means subtraction. This is addition, so I'm going to leave my answer as it is. Okay, guys, if you feel comfortable and we have a little bit of extra time, feel free to jump ahead to the homework or the IXL practice. If not, you can meet me for our optional Teams meeting on Thursday at 12:30, or if you can't make that meeting, you can just go ahead and jump right to the homework and the IXL practice. Have a good day.